In this video, we'll present a new and convenient way on how to learn electronics using the ADALM1000 Active Learning Program Kit that is especially created by Analog Devices Incorporated for students like us. This kit is an easy-to-use tool that can better understand the real analog world around us through hands-on that is available to anyone at their own pacing. But before anything else, let's take a look what this kit contains. Upon opening the kit, a piece of paper welcomes you that contains all of the necessary infos you need to know before using this kit. Now, let's get to the real thing. Next is the ADALM1000 tool that has some nice and cool packaging and awesome features as well, which we'll focus on the following minutes. Last but not least item for this unboxing are the cables that are needed for connecting the ADALM1000 to your personal computer while integrating it with your created circuit. Now, let's get back to the README paper we saw earlier. This paper includes different standard rules and codes for the user's information. Also, this paper has the list of links where the user can access to gain more information about the ADALM1000 and download some simulation softwares and files for them to use. The ADALM1000 is protected by an acrylic board which contains the main processor of the learning module. This device is designed to introduce the fundamentals of electronics and electrical engineering in a self-paced setting. Also, as mentioned earlier, the ADALM1000 has a USB cable that can be used to connect personal computers as for both power supplies and simulation purposes. Along with it are the cables for the circuit proper, including the grounding and the power supply. Also, the kit contains a 6-pin holder to hold the separable cables together when not in use. So now, let's put this learning module into action through experimentation. Many experiments are possible using the M1K and Pixel Pulse software. However, to limit our discussion, we will focus on building an amplifier. For more experiments, visit wiki.analog.com. For the materials needed in this experiment, we need a solderless breadboard, 3 NPN and 1 PNP transistor, 2 switching diodes, a bunch of capacitors for bypassing, a 100-watt output, 8 ohm impedance speaker, and of course, the resistors. The objective of this activity is to gain insight into the push-pull output stage, or can be called as a Class AB amplifiers, and also understand crossover distortion and the use of negative feedback to reduce errors. A very simple and easy way to build Class AB audio amplifier is by using 4 transistors as shown here. In Class AB operation, each output device conducts more than half of the input signal cycle. Up to 78% efficiency is possible with Class AB designs, and crossover distortion is reduced. The circuit shown here is suitable for small radio receivers, audio players, intercom, telephone, and more. If the simulation is successful in working, it is time to proceed in building the circuit using the materials gathered. For the first stage, transistor Q1 with its associated components are wired as a pre-amplifier stage, whereas the audio input is coupled to the base of Q1 through resistor R1 and capacitor C1. The resistor R3, however, provides collector to the base bias for Q1. C3 is an AC bypass capacitor for the collector resistor R4. Collector to base biasing is a good method of biasing for circuits like this, as it provides enough negative feedback, prevents thermal runaway, and stabilizes the operational point. After the first stage or the pre-amplifier circuit is completed, we can now move on to the second stage, whereas it is the driver stage for the push-pull pair. The Q2 with its associated components perform the task as the driver for the push-pull pair. This stage is also collector to base biased, and its input is coupled to the output of the pre-amplifier stage using capacitor C2. Resistors R8 limits the collector current of Q2. Of course, for the amplifier to be able to function well, a power amplifier circuit or third stage, as it is mentioned in this circuit, is the class AB push-pull section comprising of the transistors Q3 and Q4. Diodes D1 and D2 provides the bias voltage for the push-pull stage. The output of the amplifier is coupled to the loudspeaker through capacitors C4, C5, and C6. Here, we will show you how to use the ADALM kit. First, connect the wires responsible for the input or output of the circuit. Identify the connections for the input of channel A. The white wire corresponds to channel A and the black one for the ground. Next, for the channel B connection, place the wires accordingly to its color code, which is white, but make sure that the wire is connected for channel B in ADALM. Make sure that the grounding of channel B is also connected to the ground. And lastly, the red wire is connected to VCC for a 5V voltage source. For the ADALM to work, connect the USB connector of the kit to the computer and notice that it should light up once you plug it in your computer. For the simulation of the circuit, the analog devices incorporated provided a program that is suitable for the ADALM1000, the Pixel Pulse. The Pixel Pulse is an oscilloscope for PC and features some of the function of a regular oscilloscope that can be seen in this menu bar. The signal of channel A can be configured, but let's use the sine wave for this time. Same goes to the channel B, so we can compare both signals easily. Let's change the duration of the sample time of the simulation to 100 milliseconds and make sure that the repeated sweep is toggled. To start the simulation, let's change the output measurements to measure voltage, source current, so we can see the trend of the voltage. For this time, let's change the frequency input to 60 Hz. Minimum voltage to 1.5 volts. And maximum voltage to 3 volts. Here we can see the output voltage moves up and down. But it can be better seen if we change the sample time to different scales. It can be best seen if we change it to 10 milliseconds. Here we can see the output voltage is clipped to half of its input voltage. You can also change the size of the wave and observe its behavior on the output wave. To see the trend of the current, you can also change its configuration to sine wave. Now, for the actual testing, let's input the 5V power supply and its grounding from the ADALM1000 that is connected from the PC. Now, using the 8-ohm impedance 100-watt speaker, let's connect its grounding and input to the output connection of the circuit, like how we connected the channel B of the ADALM. And then, for the input of this circuit, we're going to use a 3.5mm audio jack and place its terminals to the input of the circuit, like how we placed the input of the ADALM channel A. To test the circuit, we're going to play a song and directly connect the jack to our phone.
Me and my friends at the table doing shots, tripping fast and then we talk slow. Come over and start up a conversation with just me, and trust me, I'll give it a chance. Now take my hand, stop it, turn the man on the jukebox, and then we start to dance. And now I'm singing like, girl, you know I want your love. Your love was handmade for somebody like me. Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead. I'm in love with the shape of you. We push and pull like a magnet do. Although my heart is falling too. I'm in love with your body. Last night you were in my room, and now my bedsheets smell